Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 2342. Maximum sum of a pair with equal sum of digits. This question has been asked in Bloomberg, Microsoft, Amazon. It is based out of the concept of hash table. Let's have a look on the problem statement. You are given 0 index array nums containing only positive integers, and you have to choose two indices I and j such that they should be different. And sum of the digits of the numbers num I is equal to nums j. We have to choose two indices I and j from the given array such that these two should be different. We should not choose the same number. And apart from that, if both of these indices are having a number whose sum of digits are same, let's say one number is 15 and second number should be 24, like this. Now what we have to return? Return the maximum number of nums I plus nums j that you can obtain over all the possible indices of I and j. There might be the possibilities that we have multiple options, multiple ij pairs where the sum of the digits in both the number at I and number at j are same. Then among them, whatever pair is going to give us the maximum sum, we have to return that. Even in the constraints, all the numbers are positive. Okay, let's see. Given is an integer array where all the integers are positive. What operation I have to do? I have to choose two indices I and j which are not same such that the digit sum of nums I and nums j is same. Let's say if I choose two indices, this one and this one. What are the sum of the digits? For 18, sum of the digits are 1 plus 8, which is 9. For 36, sum of the digits are 3 plus 6, which is also 9. Here, if the sum of digits are same, these are same, then we have to get the value of 18 plus 36, sum of these values. And from all of these pairs, we have to get the maximum value. Let's say this pair is having sum of digits same. If I choose this one, 4 plus 3, which is going to give me 7. The 7 is also 7. This is also going to form a pair, 43 plus 7, which is 50. But previously we were getting 54. So we are going to get 54. 54 should be our answer. 50 is rejected. Okay, two integers we have to choose such that the digit sum should be same, and the value that we have to maximize is nums I and nums j. Or whatever the maximum value, we have to return that. This is the whole problem statement. And now let's try to build the approach. First of all, what would be the brute force for this? We have to choose two indices I and j such that the sum of digits at I and j are same. If we have to choose two indices, why don't we just have two loops? One loop for I, second loop for j. And then I can check whether at I value and j value are having same sum of digits. If that is the case, I'll just capture the maximum value, and for the maximum I can take a global variable. If this is the approach we are going to follow using two loops, then time complexity will definitely be order of n square. What about the space complexity? Not a space complexity here, but time complexity is going quadratic time. But let's try to see if we can do something better than this. If this is our example, first of all, we are concerned about the maximum answer. We are initializing with -1y because all the integers are already positive. So even if we get a pair, -1 is always less than that. So initialized my answer. And apart from that, I am concerned about two indices I and j such that value at I and value at j, this is my candidate when the digit sum of I is equal to digit sum of j. If this condition is true, then this is my candidate, and I need to know all the candidates. Previously we captured all the candidates using two loops. Now in this case we will try to utilize that, try to improve that time. See, first of all, we are concerned about the digit sum. Let's say we are having some utility class which is going to utility function which is going to give me the digit sum of any number. Okay. And what is going to be the digit sum for these numbers? 18, 43, and they are going to have these values 9, 7, 9, 7, 4, 7. This is the digit sum for every number in the array. And these are the indices. From these indices, we have to choose two numbers where the digit sum is same. If I just have a look, this 9 is equal to 9. It means index 0 and index 2 are going to give me the same digit sum. If the digit sum at index 0 and index 2 are same, then check for the candidate. This is the candidate. Value at 0, value at 2, that is 18 plus 36, which is 54. So 54 is my one candidate. And now what about the other? If I further try to analyze, this 7 and this 7 is also same. Digit sum at index 1 and index 4 are same. What is the value at index 1? That is 43. What is the value at index 4? That is 7, which is equal to 50. 50 is another candidate. So among these candidates, whatever is the maximum, that is going to be my answer. Answer, I can directly see that 54. I don't see any other possible pair. So only two pairs were there. Now how did I solve this problem? See, we are worried about two indices, I and j. What should be the order of I and j? We are not concerned about the order. Let's say the array is something like this: 1, 2, 3, 4, 5. 0, 1, 2, 3, 4. My main concern is that we are going to cover every pair where the digit sum is same. If let's say the j is at this position, j is 1, then I can be from this location and I can be from this location. Let's say I is this. But in the next time, when I am choosing this I as j, then this j will become my I. So in this case, just to avoid this conflict, what we are going to do is, we are going to check only in one direction. If j is at 1, just check all the possibilities on the left side. If j at 2, just check all the possibilities on the left side for I. If j at 3, check all the possibility on the left side. If j is at 4, we will be checking all the possible pair on the left side for I index, such that the value of that digit sum value of that number is equal to digit sum value of the number which is at 4. Okay. So in this case, we are checking in only one direction, and let's say I have chosen this j equal to 4. Let's say this is one of the part of my pair I, j. It means that whatever the digit sum, let's say digit sum is ds for j, then for I it should also be ds. And how do I get to know? How do I get to know the number from the left side which are having digit sum equal to ds? For that, if I just utilize a data structure which is called map. In the map, I can keep my key as digit sum. And what is the value? All the numbers where the digit sum is equal to this integer. So if I just utilize this kind of map data structure, when I'm at j, I will directly get to know what are all the values which are going to form pair with j. And my goal to form the pair is that I have to maximize this value. If I have already fixed j, then what I should choose? The I will choose where the digit sum is equal to this key and the value is maximum. Magnitude of that value is maximum. So instead of taking this integer list, I can take an integer which is the maximum integer. So for every j, what I need to know is, I need to get a number on the left side which is having same digit sum, and that value should be maximized. So I should maintain my map such that map is going to get a key which is equal to the digit sum, and the value is going to be the maximum value of nums of I where digit sum is equal to key. In this case, what I'm going to get? I am going to get that for every j is going from 0 to n minus 1, or you can precisely say going from 1 to n minus 1. This is the indices for j, and I am going to choose I. Only one I, whatever is going to give me the maximum value. And valid I means where digit sum is same. For every j, I will be able to get this value in a constant time because I am utilizing hash map data structure. So if I am able to get the maximum value of nums of I for every nums of j, and nums of j will go from 1 to n, it is going n times. N possibility of j we are having, and for every n possibility we are going to get the value of nums I in a constant time. So overall the time complexity will be reduced to order of n in this case. Now you may wonder what is going to be the time complexity for finding the digit sum. Finding the digit sum is not that difficult. Like at max, how many digits are going to be in this number? Maybe 20, maybe not more than that. So that I am considering as a constant value. And apart from that, the space complexity will also be there. Space complexity will be order of n. So now I am able to solve this problem using a map data structure and doing one iteration from left to right. What is going to be my algorithm? So I will be going from left to right. I will be firstly checking the key and see whether the key is already present. It means we will be able to get the pair. If it is already present, get the pair and capture the maximum value. If it is not present, then just capture it. We are not going to get the pair. Now let's try to code this approach. Then you will get more understanding of the algorithm. It's going to be pretty simple. See, first of all, we should be having one utility class which is going to give me digits sum. Digits sum is going to be taking a number, integer number, and going to return integer. What is this integer? Integer is sum of all the digits, returning sum. Now I need to run a while loop. While this number is greater than 0, I'm going to modify the input. Just capture the rightmost digit. And how do I capture the rightmost digit? Sum plus equal to num, take a modulo with 10, and then just discard the rightmost digit by dividing it with 10. Now we are having the sum of all the digits. Here as a helper data structure, I'm going to take a map of integer, and this is my map, hash map. And let me also capture the length of this array. Okay, so in this case, let's go and iterate over this array I less than n, I plus plus. What is my answer? Answer is -1 if I am not able to find any pair. Return answer. So now I need to get the key. And what is the key? Digits sum of nums of I. Now I have the key, and now it means I'm having the j value, but for the I value, whatever is the maximum value I'm going to have, that I'm assuming already present in the map. So let's say for the left part, how do I get that? I need to check whether it is present in the map or not. Map dot contains key. Map dot contains key. If it is present in the map, then just get the value. Answer is equal to math dot maximum. What is the current answer? And apart from that, map dot get key. Because map dot get key is going to give me the maximum value of nums I. But nums j we are already having nums j, with that is nums of I in this case because of the I pointer. Don't get confused with that. This is the case when the key is present. If the key is not present, let's see what will happen in that case. We are not going to get the pair. And now after that, we just have to store the new key. New key is going to be the existing key with maximum value of num size. So map dot put key comma this. And in this case, what I'm going to put as a value I'm going to get the existing value math dot maximum. Existing value is map dot get I, and the new value can be nums of I. So I just updated the existing key. Key is a digit sum with the maximum value of nums from the nums. But if the key is not present, then I just have to directly put it. Map dot key comma, what is the value? Value is nums of I. Directly put the value. So in this case, let's say when I'm going to the next iteration, I'm having my map fulfilled with the updated key, and I'm going to get the value as well. Value will be either any previous value or the current value. Okay, got it. So I think this much we have to do. Taking a map, getting a digit sum. Digit sum is going to be the key, and the value is value from the given array. If the value is already present, it means we might find a pair. If we might find a pair, then we definitely get some candidate. Otherwise, we just have to put it in the map. Let me run over sample test cases. Sample test cases are passed. I'm submitting the problem. It got submitted successfully. I hope you understood the approach. If you have any doubt, you can ask me below in the comment section. Thank you guys. Bye-bye.